Have you ever looked at something so ordinary that you never stopped to ask the biggest question about it? Take a moment. Look at your own hands. Look at the air around you. Listen to the sound of my voice. Now, here's the strange part. Scientists can tell you how stars are born. They've sent machines beyond the edge of our solar system. They've discovered particles smaller than atoms and captured images of black holes millions of light years away. And yet, there are things right here, right now, that the greatest minds on Earth still cannot fully explain. Isn't that incredible? We often imagine science as a giant book filled with answers, but that's not what science really is. Science is a never-ending adventure of questions. Every answer opens 10 new mysteries. Every discovery reminds us of how little we actually know. The most exciting sentence in science isn't, "We found the answer." It's, "We don't know," because that's where discovery begins. Today, I want to take you on a journey into some of the greatest mysteries that continue to puzzle scientists. These aren't fantasy stories. These aren't conspiracy theories. These are real questions that researchers spend their entire lives trying to solve. Why does consciousness exist? What is most of the universe actually made of? Why does quantum physics behave so strangely? Why is gravity so incredibly weak compared to the other forces of nature? And perhaps the most fascinating question of all, why does reality seem far stranger the deeper we look? The universe is not just stranger than we imagined. It may be stranger than we are capable of imagining. And that's exactly what makes science beautiful, because every mystery is an invitation to think, to question, to wonder. And today, together, we're going to explore the questions that science still cannot answer. Let me ask you something that sounds incredibly simple. What do you think the universe is made of? Most people would probably answer, stars, planets, galaxies, people, animals, rocks, water. And that seems like a perfectly reasonable answer. Everything you can touch, everything you can smell, everything you can see around you must make up the universe, right? Well, that answer is almost completely wrong. Imagine walking into a giant library with millions of books. You proudly say, "I've read everything here." Then someone smiles and says, "Actually, you've only read one page." That is surprisingly close to our situation. Everything we have ever seen, the earth beneath our feet, the moon hanging in the night sky, the sun that warms our planet, every galaxy captured by our most powerful telescopes, every human who has ever lived, every animal, every mountain, every ocean, every grain of sand, together they make up only a tiny fraction of what exists. Think about that for a moment. The chair you're sitting on, the device you're watching this on, your heartbeat, the air filling your lungs, even the billions of stars scattered across the night sky, all of it belongs to a very small slice of reality. So naturally, the next question is, what makes up everything else? That's where science enters one of its greatest mysteries. Astronomers have spent decades studying galaxies. They measure how stars move, how galaxies spin, and how enormous clusters of galaxies behave across unimaginable distances. And something very strange keeps happening. According to everything we know about gravity, galaxies should not behave the way they do. Imagine tying a ball to a string and spinning it around your head. If the string suddenly disappeared, the ball would fly away. Now imagine the stars inside a galaxy. The stars near the outer edge are moving so quickly that according to the amount of visible matter we can detect, they should simply escape into space. But they don't. They stay exactly where they are. It's almost as if some invisible hand is holding the galaxy together. But when scientists look for that invisible substance, they can't find it. not because they haven't tried. They've built underground laboratories buried beneath mountains. They've designed detectors so sensitive that they can notice the tiniest interactions imaginable. They've launched space telescopes. They've created enormous particle experiments. And yet, whatever this mysterious substance is, it refuses to reveal itself. Scientists gave it a name, not because they understood it, because they didn't. They called it dark matter. Notice something interesting about that name. It doesn't explain anything. It's simply a label for a mystery. It's like finding mysterious footprints in the snow and saying, we'll call whatever made these the footprint maker. The name isn't the answer. It's simply a reminder that something unknown exists. Now, here's where things become even stranger. Suppose I told you dark matter wasn't even the biggest mystery. There's something even more puzzling. For centuries, gravity was expected to slow the expansion of the universe. Think about throwing a ball into the air. It rises, it slows down. Eventually, gravity wins. Scientists expected the universe to behave the same way. After all, every galaxy pulls on every other galaxy through gravity. So over billions of years, the expansion should gradually become slower. That prediction sounded perfectly reasonable, until astronomers actually measured it. What they discovered shocked the scientific world. The universe isn't slowing down. It's speeding up. Imagine driving your car. You take your foot completely off the accelerator, yet instead of slowing down, the car starts moving faster and faster on its own. Your first thought would probably be, something is seriously wrong. Either your understanding of the car is incomplete, or there's some hidden force you don't know about. That's exactly how scientists felt. Something appears to be pushing the universe apart faster every second, but no one knows what it is. Again, they gave the mystery a name, dark energy. Notice the pattern, dark matter. Dark energy. The names sound impressive, but they are really honest admissions that science has discovered something without yet understanding it. And personally, I think that's beautiful, because many people imagine science as a collection of facts carved into stone. Science isn't that. Science is humanity standing in front of an enormous ocean of mystery with a tiny flashlight. Every year, the flashlight becomes brighter. But as it does, we discover that the ocean is even larger than we imagined. The more we learn, the more questions appear. Now let me make this even more personal. Every atom inside your body was forged inside ancient stars. The calcium in your bones, the iron flowing through your blood, the oxygen you breathe. Long before Earth existed, those atoms were created in exploding stars scattered across the universes. You are literally carrying pieces of ancient stars inside your body. And yet, the matter you're made of seems to represent only a tiny fraction of everything that exists. That means you are living in a universe where most of reality remains invisible. Not hidden because someone is keeping a secret. High because nature has not yet revealed the answer. Think about how extraordinary that is. We can predict eclipses hundreds of years into the future. We can send robotic explorers to distant planets. We can detect tiny ripples in space and time caused by collisions between black holes billions of light years away. Our technology has become astonishing. But if someone asks one of the biggest questions imaginable, what is most of the universe actually made of? The most honest answer science can currently give is, we're still trying to find out. And I believe that answer is far more exciting than pretending we already know everything, because every generation has believed it understood the universe. Then a new discovery changed everything. Perhaps someone sitting in this audience, perhaps someone watching this speech years from now, will become one of the people who finally solves one of these mysteries. History has taught us something remarkable. Every impossible question eventually becomes tomorrow's textbook. The greatest discoveries often begin with a single person refusing to stop asking why. So the next time you look up at the stars, don't just admire how beautiful they are. Remember that almost everything surrounding them remains unknown. The universe is not finished revealing its secrets. And that means we are living during one of the most exciting moments in the history of science. Not because we know all the answers, but because the biggest questions are still waiting for someone brave enough to ask them. Let me take you somewhere that no one has ever seen with their own eyes. Not because it's too far away, not because it's hidden behind a mountain, but because it's so unbelievably small that our everyday experience completely fails to prepare us for it. Imagine shrinking yourself, not to the size of an ant, not to the size of a grain of sand. Keep shrinking, smaller than a single cell, smaller than a virus, smaller than a molecule, smaller than an atom itself. Eventually, you would arrive in a place that follows rules unlike anything you've ever experienced. A place where common sense seems to stop working. A place where reality behaves more like a mystery than a machine. This place is the quantum world. Now, before we go any further, let me make something clear. When people hear the word quantum, they often imagine science fiction, magical powers, or impossible technology. But quantum physics is none of those things. It is one of the most successful scientific theories ever created. Without it, we wouldn't have smartphones. We wouldn't have lasers. We wouldn't have modern computers. We wouldn't even have the technology that allows us to communicate across the globe in seconds. Everything around us quietly depends on quantum physics. And yet, even the scientists who spend their entire lives studying it will often admit something remarkable. They understand the mathematics. They can predict the results with astonishing accuracy. But explaining why nature behaves this way, that's another story entirely. Let's begin with something that sounds impossible. Imagine you're standing in front of two doors. Behind one door is your friend. Behind the other is nobody. Normally, your friend has to be behind one door or the other. That feels obvious. Now imagine someone tells you your friend is somehow behind both doors at the same time, not switching back and forth, not moving incredibly fast, actually existing in both possibilities simultaneously. You would probably laugh. You'd say that's nonsense. And in our everyday world, you'd be absolutely right. But tiny particles don't always behave the way everyday objects do. One of the most famous experiments in science is called the Double-Slit experiment. It's surprisingly simple. Scientists fire tiny particles toward a wall containing two narrow openings. Behind those openings is another screen that records where the particles land. If these particles behave like tiny marbles, each one should travel through one opening or the other. Civil. Predictable. Exactly what you'd expect. But that's not what happens. Instead, the final pattern on the screen looks exactly as if every particle somehow traveled through both openings simultaneously and interfered with itself like a wave. Think about that. How can something interfere with itself? It's like throwing a single pebble into a pond and watching it somehow create two separate waves that collide with each other. It doesn't make sense. Yet, experiment after experiment keeps producing the same astonishing result. Now comes the part that leaves even experienced physicists scratching their heads. When scientists place detectors near the openings, to observe which path the particle actually takes, everything changes. Suddenly, the strange wave-like behavior disappears. The particle behaves as though it chooses one path after all. It's as if nature somehow knows when you're looking. Now, be careful. This does not mean human thoughts magically control reality. That's a common misunderstanding. The real mystery is far more subtle. In quantum experiments, making a measurement changes the physical situation. The act of interacting with the system affects what happens. Exactly why this works the way it does remains one of the deepest questions in physics. Scientists have proposed many interpretations. Some suggest the particle never had a definite path until it was measured. Others suggest every possible outcome exists in separate branches of reality. Still others argue that our understanding of measurement itself is incomplete. Notice something fascinating. These are not arguments between people who don't know physics. These debates happen among some of the smartest scientists alive because the experiments are clear. The mathematics is extraordinarily successful. But the meaning behind it, that remains uncertain. Now let's make things even stranger. Suppose I have two special coins, not ordinary coins. Quantum coins, I separate them. One stays with me. The other travels millions of kilometers away. Now imagine I check my coin. Instantly, I know something about the other one. No signal appears to travel between them. No visible connection exists. Yet somehow the two particles behave as though they remain linked, despite the enormous distance separating them. Scientists call this quantum entanglement. When this idea was first discussed, many people thought it had to be wrong. It seemed too bizarre. Even one of history's greatest physicists struggled to accept it. He famously described it as spooky action at a distance. Not because he believed in ghosts, because the phenomenon seemed so deeply strange. For decades, scientists wondered whether there must be some hidden explanation waiting to be discovered. Then experiments became more precise. Again and again, nature sided with quantum physics. Today, entanglement is no longer just a curious idea. Researchers are actively using it to develop quantum communication and quantum computing technologies. Imagine trying to explain Wi-Fi to someone living 500 years ago. They would probably think it was magic. Perhaps future generations will look at quantum technology the same way. What seems mysterious today may become completely ordinary tomorrow. But even if we learn how to use these effects more effectively, one enormous question remains. Why does reality work like this? Why doesn't the universe follow simple, comfortable rules that match human intuition? Perhaps because the universe was never designed to satisfy human intuition. Our brains evolved to survive on the African savanna. We evolved to throw rocks, to recognize faces, to avoid predators. We did not evolve to understand particles smaller than atoms. Maybe reality isn't strange. Maybe we're simply encountering parts of nature our minds were never built to imagine. Think about how humbling that is. Every day we trust our senses. We believe what we see. We believe solid objects are truly solid. But look closely enough, and atoms are mostly empty space. Look even deeper, and particles stop behaving like tiny billiard balls. Instead, probability, uncertainty, and waves become part of the story. Reality becomes richer than our intuition. This teaches us something profound. Nature has no obligation to match our expectation. The universe does not ask whether an idea feels comfortable. It only asks whether it is true. And that's one of the greatest lessons science offers. Real discovery often begins at the exact moment when reality refuses to behave the way we expected. The history of science is filled with moments like this. The Earth wasn't the center of the universe. Time wasn't absolute. Space wasn't empty. Light wasn't simply a wave. Matter wasn't completely solid. Again and again, humanity has been forced to replace certainty with curiosity. Quantum physics is perhaps the greatest example of that journey. It reminds us that the deeper we explore reality, the less we can rely on intuition alone. Instead, we rely on careful observation, careful experiments, careful questions, and the courage to accept answers that seem unbelievable at first. Perhaps that's why quantum physics continues to fascinate millions of people around the world, not because it gives us all the answers, but because it reminds us that the universe is under no obligation to be simple. It is more creative, more mysterious, more surprising than our imaginations ever expected. And maybe that's exactly why we should never stop asking questions, because somewhere inside this strange quantum world may be the next revolution in science, or perhaps the next revolution in the way humanity understands reality itself. Let me leave you with what I believe is the most important idea in all of science. It isn't an equation. It isn't a law of physics. It isn't a revolutionary invention. It's a simple sentence. I don't know. Those three words may sound ordinary, but they have changed the course of human history more times than we can count. Think about it. Imagine living hundreds of years ago. Every morning, the sun rises in the east and sets in the west. To anyone watching, it looks obvious that the sun is moving around the earth. If someone had asked, why does the sun move across the sky? Most people would have answered with complete confidence. Confidence is comforting, but confidence is not always the same as truth. Then a few curious people did something unusual. Instead of pretending they already understood everything, they admitted something that many people are afraid to say. We're not sure. That simple admission opened the door to a completely new understanding of the universe. The Earth wasn't the center after all. The planets weren't following perfect circles. The heavens weren't fixed and unchanging. Everything people thought they knew had to be questioned. Now imagine if those scientists had refused to ask questions because they were afraid of looking ignorant. Imagine if they had said, everyone already believes this, so why challenge it? Human progress would have stopped. Every great scientific revolution begins with someone who is willing to be uncertain. That's the secret. Science isn't a collection of people who claim to know everything. Science is a community of people who are comfortable saying, let's find out. And I think that's a lesson all of us can use, not just in laboratories, but in everyday life. We live in a world where people often feel pressure to have an answer for everything. Social media rewards certainty. Argument reward confidence. Sometimes the loudest voice in the room is treated as the smartest. But reality doesn't work that way. Nature doesn't care how confident we sound. Nature only responds to evidence. You can argue with gravity all day. Gravity will still win. You can dislike mathematics. The equations will still describe reality. Truth isn't decided by popularity. It's discovered through curiosity, observation, and testing. That is why saying, I don't know, is not a weakness. It is the beginning of wisdom. Think about children for a moment. Have you ever noticed how many questions they ask? Why is the sky blue? Why do birds fly? Where do stars go during the day? Why do we dream? Why does the moon change shape? Sometimes adults become exhausted trying to answer all those questions. But children are doing something remarkable. They're behaving like scientists. They're not embarrassed by what they don't know. They're fascinated by it. Somewhere along the way, many adults lose that habit. we begin to worry about looking foolish. We stop asking questions because we think we're supposed to already know. But the greatest discoveries have always belonged to people who never outgrew their curiosity. Consider this. When Isaac Newton saw an apple fall, millions of people before him had watched objects fall from trees. The apple wasn't special. What was special was the question, why? That single word transformed physics. When people noticed mysterious diseases spreading through cities, many accepted it as fate. Others asked, what causes disease? That question eventually led to modern medicine. When engineers dreamed about flying, most people laughed, birds fly, humans don't. But someone asked, why not? That question eventually filled the skies with airplanes. Every extraordinary achievement begins with an ordinary question. Science is not powered by certainty. It is powered by curiosity. And curiosity always starts with admitting that there is something we do not yet understand. Now let me ask you another question. What do you think future generations will laugh about? Perhaps 100 years from now, students will open a textbook and read about dark matter, the same way we read about ancient mysteries that have already been solved. Maybe quantum gravity will become as familiar as electricity is today. Perhaps diseases that frighten us now will seem as treatable as a common infection. Maybe traveling to Mars will feel as ordinary as boarding an airplane. We don't know. And that's exciting, because the future is still unwritten. Somewhere in the world today, a young student is asking a question that nobody else has considered. Maybe that student will discover a new law of physics. Maybe they'll invent a technology that changes civilization. Maybe they'll solve a mystery that has puzzled scientists for centuries. History tells us that breakthroughs rarely announce themselves in advance. They usually begin quietly. A notebook, a question, a failed experiment, another question, another failure. Then suddenly, everything changes. People often imagine scientific discovery as one brilliant moment of inspiration. Reality is much less glamorous. Scientists fail constantly. Experiments don't work. Predictions turn out to be wrong. Equipment breaks. Years of effort sometimes produce nothing at all. But failure isn't the opposite of discovery. It's part of discovery. Every failed experiment removes one wrong answer. Every unexpected result teaches us something new. Thomas Edison once said he hadn't failed. He had simply found many ways that didn't work. Whether or not every version of that story is perfectly remembered, the idea captures an important truth about scientific progress. Knowledge grows step by step, not by pretending mistakes never happened, but by learning from them. And that's another reason science is so powerful. Science doesn't demand perfection. It demands honesty. If your experiment proves your idea wrong, you don't hide the result. You celebrate it. Because reality has just taught you something valuable. Imagine if we all approached life that way. Imagine being willing to change your mind when new evidence appears. Imagine valuing truth more than winning an argument. Imagine replacing certainty with curiosity. The world would probably have fewer conflicts and far more discoveries. Now, let's return to the night sky one last time. Every star you see is a reminder that there are questions still waiting to be answered. Some of those stars may have planets. Some of those planets may have oceans. Some may even have life. We don't know. And that's one of the most thrilling sentences in the English language. We don't know. Those words are not the end of the conversation. They're the beginning. They're an invitation. An invitation to observe more carefully, to think more deeply, to test ideas instead of assuming them, to remain humble in the face of a universe that is older, larger, and stranger than anything we can fully imagine. So, the next time someone tells you that science has already explained everything, remember this. The greatest scientists in history were never remembered because they claimed to have all the answers. They were remembered because they had the courage to ask better questions. The universe still holds countless mysteries. Some are hidden in the depths of space. Some are buried inside the smallest particles imaginable. Some may be hiding in places we've looked 1,000 times without noticing. The next great discovery could happen tomorrow, or next year, or decades from now. And it might begin with someone who is brave enough to look at the world, smile, and simply say, I don't know. Because those 4 simple words are not an admission of defeat. They are the first step toward every great discovery humanity has ever made, and perhaps toward the next one.